We see that we're being recorded. Yeah, just a couple of things, and maybe if you could write into the chat, like to know how many folks are contractors and consultants in the solar world, and how many folks are in enforcement. See how many folks we have in each category, but nice to know who we have on the call. I've been doing trainings in Santa Barbara and the region around there, up to Santa Maria and down to Ventura, for well over 20 years. And I'm trying to think back, one of my first times in Santa Barbara, back probably 21, 22 years ago, when I gave my first training there. So love the area. Why wouldn't you? Obviously, wonderful place to be. And there certainly is a fair amount of activity in solar and energy storage. And so one of the things that we're going to focus on, so I'm going to go over some common issues that we see with solar stuff. And this is part of an inspection procedure that was put together with the AB 2188 materials for permitting. Many of you are familiar with those permitting, standard permitting documents that the Sustainable Energy Center still supports. However, many communities have actually picked up the solar app, and so there's, I don't know how many communities are in the Tri-County area have solar app, but maybe April knows, but that's certainly a program that's coming along, and there's quite a few jurisdictions in California now using that, at least as a in a test method for a while, and that's really gaining a lot of steam. So we're going to spend a fair amount of time talking about energy storage systems as well, since that's kind of a hot topic, and talk about the details of the code, which really end up being the permitting and the inspection process that we have to observe with energy storage systems in and around homes. And so, of course, a lot of these procedures and all can work well with virtual inspection systems. I know a lot of communities did virtual inspections as a matter of just practicality during COVID. And now that folks are doing a lot more in-person inspections, it would be interesting to find out what communities are still doing virtual inspections versus or a combination or a hybrid of them, to determine how that's proceeding. But obviously COVID brought a lot of those technologies to the fore, and some very interesting stuff. And so, you know, we can see how these various activities and inspections can help communities provide these services. A lot of these materials came out of some training materials I did for Calbo, and so that's why you'll see Calbo at the top of some of these things. And California building officials, I've done training for them for quite a while, and they provide some great educational resources for enforcement in California. So just looking at the inspection process, we're just going to run through a fairly simple and straightforward inspection process that covers the high spots. As we go along with this, if there's questions that come up that relate to the materials here, feel free to put that in the chat, and I'll try to keep a look at it, and April's going to try to help me as well, to make sure that we answer your questions in a timely manner as we go through these things. But if we're doing an inspection, normally we're we're going to have all the disconnects in the off position. We're preparing for the local inspector to come take a look at things. Obviously, these switches are in the on position because the system's been inspected and operating. And that's a really old school inverter there. If somebody remembers that, they can put it in the chat. All work done in a neat and workmanlike manner. One of the things when we were putting together this latest, it's not that late, but this particular inspection checklist was the basic concept in the National Electrical Code that electrical work should be done in a neat and workmanlike manner. That's in the 110.12, and although that is subjective, what we're really trying to get at is with electrical things, if it's messy, it tends to be easier to make mistakes, easier to get things wrong, easier to get things damaged. And the picture on the left is really an example of the fact that we can see up underneath our PV arrays, and by what I like to tell contractors is to attempt to make it look like wireless technology, so that people have to really scratch their head to figure out how in the world you got the power from the roof down. And the more it looks like wireless technology, the better off the customer. In this particular case, this is as they're walking into their front door, they can actually see up underneath the panels. And so, they may not even be able to see the top of the panels, but they sure could see underneath them. And so doing that neatly is helpful. And then, of course, debris and all is less likely to capture underneath the panels and get leaves. And we've had some really bad examples of squirrels making homes underneath panels, and squirrels have a really bad habit of gnawing on electrical wires. And we've had actually several house fires because of squirrels living underneath solar panels. And that's a really bad thing. So, being able to see under the panels is not only an aesthetic benefit, but it also could be very much a safety issue. Well, and here's some examples of some pretty ugly stuff. Way back in the day, there was all kinds of bad stuff. And the good news is, we've improved dramatically over the years. I wouldn't say we're all done yet, but the next item on the list is just making sure that the array matches what was submitted in the permit package. And this is actually can be a challenge, just because the fact that even especially now where we have a lot of supply chain issues, modules, availability of modules. You may have submitted a permit, especially if the permit gets held up or whatever. The timing of those available modules often changes, and so plans may have to be updated, things like that. And as things move forward, we're getting more and more powerful modules. So maybe the array, the geometry of the array might change a little bit, as well as the power output of the array. So that adds additional challenges of having to resubmit information to the local jurisdiction to make sure that things are the field inspector has the right information when they go out to the site, because you don't want them to fail the project just because you had to update the module model number, and they say, well, it's not here in my paperwork. So so when we're looking at the site diagrams for these things, calling out where the array is going to be installed on the roof, how it's being attached to the roof, it's got the right fire ratings, all that kind of stuff. But the location, this is to show that we have access pathways available on the roof as the code requires. Here's an example of a installation, happens to be down in the Long Beach area. Hopefully this is long gone, but this was a pretty horrible installation. And one of the things that it did do, certainly structurally, it had some significant issues, as well as aesthetic issues, but also you're not going to see probably any solar projects within a mile or so of this house, because folks that live in that community are going to drive by that house and go, wow, if that's solar, I'm not going to have anything to do with that. So part of doing things well and doing things aesthetically and cleanly and neatly is that other customers, other people will want that. And given our high electrical rates in California, makes a lot of sense. Roof penetrations, array mounting system, and structural connections according to the approved plan. So when we do a plan submittal, we're going to submit what kind of rails and attachments and structure we're using. Also, most of the rail systems nowadays have UL 2703 grounding and bonding options, and so to the extent that we can use those, that certainly makes the approval process a lot cleaner. Here we see this is on the left-hand side is a flashing that's specifically designed for that style of roofing, which happens to be a metal roofing. On the right, which is standard comp shingle, you can see that the flashing was not even installed. So we're dealing with a contractor here who doesn't know how to do flashings, and there's wires hanging down all over the place. They had the wrong clips on the rails. You had all kinds of problems in this installation. So this was not the one on the right was not installed by a contractor with qualified people. They hadn't trained their people. So we want to make sure that any penetrations that we have in the roof are flashed. Now, the code is a little bit wishy-washy on this particular item, or at least it's open for subjective guidance on this, in that a penetration is considered something like a pipe, a vent pipe for plumbing and the like. Those are penetrations. A fastener is not at all defined as a penetration in the NEC, in the building code, the residential code of the building code. So I know that there's some great materials out there and great products for flashing around lag screws and stuff like that go into the roof, and I certainly encourage people to use those products. To say that the code requires those products a little bit, maybe a little bit on the extreme side, but there's been a lot of talk in the building code about putting a little more definition to those attachment issues and when attachments require flashing and things like that. But if you're going to use a flashing like this is the one on the right is designed for, then please install it correctly. Okay. The array exposed cables are properly secured and supported to prevent physical damage. Here we see some poorly routed cables that are, some of them being hung on the ground wire and things like that, but just hanging around. It'd be a trip hazard if you're trying to walk around on the roof. I see it again here. This would be, I like to call this the attic ventilator support system, which is not a support system, or the comp shingle roof support system, where the wire is just hanging on the roof, laying on the roof. If we want to take conductors from this point over to this point, we have these cylindrical things called conduit, and we can install a short piece of conduit, can be PVC, and sleeve our conductors and support them off the roof and protect them in that conduit. And that is perfectly acceptable and the preferred method of doing it, unless we had a piece of structure that went all the way across. So if the rail had gone all the way across, then we could have continued to fasten the conductors to that, although rails are expensive, and so per foot, so a piece of conduit is typically cheaper than that. Oops, sorry, I went too far. Okay. Exposed cable properly secured. Here's an example of a project we saw a couple slides ago, but it is challenging to take the excess cable that we have on a lot of our modules, especially when we're installing in a portrait fashion. Some people like to use the leapfrog method, I call it, where you skip every other module and come back, and that's one way to use up some of that extra cable, but that's not always possible with all products. And so we do have to secure the conductors, the excess cable, up and out of the way. We need to do it in a way that we're not going to have smaller than the minimum allowable bending radius of the cable, and that would be 5 times the diameter. The radius of the bend can be no more than 5 times the diameter. So for typical like 1/4 inch thick cable, we're talking about a 2.5 inch radius. Actually, it would be 1.5 inches, about 1.25 inch radius, or 2 inch diameter turn, 2.5 inch diameter turn. So, but here's an example where the cables were all supported up at the top and not hanging down. They're accessible if somebody needs to test a module or things like that. And this was a nice, cleanly installed system. Maybe their grounding hardware wasn't quite right, but we'll not go there at the moment. But you can see across the street, there's another PV system, and there's several on that street because they were done neatly, and so many of the neighbors decided that they wanted to go for it as well when they heard about how good that customer's electric bill was. So correctly installed conduit on the roof. Here you have a piece of flex that's just laying on the roof. That's not acceptable. It has to be properly secured and supported. Okay, so let's talk a little bit about setbacks. So there's a variety of setbacks that were introduced to the code in the 2018 IRC. They became part of the 2019 California Residential Code when that was put into effect. And so these guidelines are fairly straightforward. I was involved in developing these guidelines. And the original guidelines were a lot more complicated. I was involved in those as well, although I'm not as proud of those as the more recent ones. But basically, there's a requirement for there to be a 3-foot wide pathway from eave to ridge. And as long as there's an exit pathway on an adjacent roof, then you only need one pathway on the side of the roof where the array is. And so, so there's your pathway eave to ridge, and then you have the ridge setback that we'll talk about in a second. So there's going to be an approved plan, and we're going to show that we have access from the eave to the ridge. We have, of course, this whole area coming off the back of the roof there. Here's another example of a situation where we actually did have a fire on a home. It was actually a garage fire on a home with a PV system, and the firefighters were able to cut a hole in the attic to make sure that the fire hadn't progressed into the house. Unfortunately, it hadn't. Stayed in the garage, but they had plenty of room with their setbacks and all. So after the 2 pathways from gutter to ridge with roof on adjacent planes, that one of those has to be on the driveway or street side of the house. That's the basic requirement, because that's where the firefighter is going to most likely ladder the building, is from the street side or the driveway side of the house, because that's where they're going to pull in at. And that's why we require that pathway there, at least one of those. The ridge setback can be as small as 18 inches if the total system size is only 33% of the total roof area. And if the home has fire sprinklers, which certainly anything built in the last few years is required to have fire sprinklers, then you can go up to 66% of the total roof area. And so when we talk about total roof area, we literally just sum up how many square feet of roofing you have, and then the system size is divided into that number. And if that is 66% or less, then you can go within 18 inches of the ridge. So here's an example where we have a whole large roof area that's not being used for solar. All the solar is being grouped over here at the garage and this wing of the house. And because of this large roof area here, it's all contiguous. We're allowed to go within 18 inches of the ridge. So that's a helpful thing. Also, if we have access to get off the roof from the ridge, as we do in this case, here is our pathway to ridge on the street or driveway side of the house. We have 18 inches on either side of the ridge. We're counting this whole roof area here. And as long as this is, this can't be 8 feet difference, but we'll just say this is a step height. This is only a foot or two from this roof face to this face, then this becomes a whole area where there's the ability to exit. The reason we have the requirement for 2 pathways, just for those of you who may not understand this, is the initial pathway is the pathway that the firefighter is generally going to choose to get to the ridge of the roof if they need to work their way along the ridge. And then if this pathway that we show here on the drawing gets cut off for any reason, like the fire progresses into this area, they can no longer safely exit off of this area. They have another pathway that they can get down off the roof safely, and they don't have to climb across the solar panels or whatever. Excuse me. So roof-mounted PV systems can have a fire rating, and so the systems that are sold in California, many of them are required to have Class A fire classifications as a system, and so there are many products on the market. It's just showing a couple of them here where they have Class A fire ratings on the system. And that would apply to many different communities throughout California, any wildland urban interface areas in California. So if you are in a community and you're not sure whether or not they require Class A for their residential roofing, you can contact them and determine if the address that you're working in requires that. So here we're talking about grounding and bonding. And we want to really look for that UL 2703 listed equipment. That's been available now, readily available on the market for probably 5 years or so. If you're a contractor and you're not using UL 2703 listed grounding and bonding systems, you're probably wasting time or not doing it right. Those are your 2 options. Because to do it right without the UL 2703 listing is very labor intensive and difficult. And this would be an example of a labor intensive and difficult install. And one of the reasons that I was such a strong supporter of UL 2703 is trying to install, a number 6 bare copper conductor underneath an array and trying to turn the modules over, and that was an absolute nightmare and just not a very effective way to do it anyway. So grounding clips or clamps that actually create the bonding necessary for the module frames and the rails is the way you want to go. And hopefully most people have been doing that for the last 4 or 5 years. Equipment listed and installed according to the approved plan. So one of the one of the situations, or one of the things that field inspector is tasked with doing, is to make sure that any certification labels are on the equipment, and those certifications are correct and relevant to the installation. And so our inverters are going to have listing labels on them. The modules are going to have listing labels on them. If we have other equipment, we'll have listing labels. I mean, if we have junction boxes and things like that, they'll also carry listing labels if we're using junction boxes. And of course, our cables are marked according to the way they've been tested. And so we'll see that in a second. But going back to this one, generally you're going to see the term utility interactive on the listing label for the photovoltaic inverter. Not all inverters may have that, but I would say the vast majority of them over the years have had that marking of interactive. If it doesn't say utility interactive directly on the listing label, then of course you'd want to show documentation that the inverter is on the California eligible equipment list, which that is a requirement of the eligible equipment list. The eligible equipment list for California also includes all of the grid support requirements. And so over the years, and many of you who have been working in this field for years probably have been through several iterations of these lists where different new requirements come into the state of California, and now the inverters have to meet those new requirements. And initially, there's maybe only a few inverters that meet those requirements, and then they build over time. But if we were to find, let's say, we have an inverter from an older project, and maybe the customer moved away, and we bought the equipment back from the customer or whatever, to take that inverter and use it in a new installation, it'd be very likely that that inverter wouldn't have all the new requirements for grid support functions for California, for Rule 21 in California, and then we're moving toward communications requirements as well. So lots going on in that area. So it has to meet the requirements, has to be on these lists. Just having utility interactive on the label is helpful, but it doesn't necessarily tell you everything. Okay, conductors, cables, conduit, types, sizes, and markings according to approved plans. Here we have an example of somebody that wired just standard building wire that's supposed to be in raceways up on a rooftop. That's not going to be very good, especially with a comp shingle roof. So photovoltaic wire, PV wire, it may have other ratings on it like RHW or USE2, sunlight resistant, but PV wire and RHW and USE2 are the correct outdoor ratings. This one happens to have all of those ratings on them for any cable that's not in a raceway. So our standard plans, which whether we're using the AB 2188 standard plans, whether you're using the standard plans from SolSmart, which is if you go to solsmart.org/permitting, that has the latest versions of the standard plans that are for national use. And so I encourage you to go there. In fact, let me, trying to get to the bottom of this thing. Oh, in the chat, I can just put that in there. SolSmart, solsmart.org/permitting. And it's a nice web page with all kinds of documents and standard plans that you can use to fill in, and encourage you to go there. But obviously, this is where we call out conduit, wire, cables, type sizes, things like that. And we want to make sure that that's what we put in the field. Overcurrent devices in residential are almost non-existent nowadays. But if other than circuit breakers in the main panel and stuff like that, arrangements like that. But if you do have a situation where you're having to have string fuses and things like that, which would be more common in commercial installations, making sure that the ratings are correct. So this is 600 volt AC DC fuse, which would be used in residential applications. This is a 600 volt fuse over here, it's class R 100 amp fuse, but it's only 300 volt DC fuse. So it would not be allowed in an installation that was over 300 volts, which it's very uncommon to have that. But also, most of our commercial systems are at 1,000 volts now with 480 volt three-phase output. So 1,000 volt equipment would be necessary, of course, in those installations. Disconnects according to the approved plan. In this particular case, we're showing a situation where they combined the two inverters in a box. And back in the day, way back in the day, we were required to have visible break switches. There still are some communities out there in California that require those. Most do not. And so the circuit breakers that are in here would be acceptable. Or since this is actually within inside of the equipment, circuit breaker in here would be an acceptable turn-off, acceptable way to disconnect the AC side of the system. And of course, on the left here is the DC side. Okay, and our approved plans are going to show these disconnects. This AC disconnect is being used in this particular case, and so it's called out, but a lot of times when we have a standard plan like this and we have a call out for a meter or a disconnect, it may not be used, and we just have NA under those in a standard plan arrangement. Here's an example where the DC disconnect is next to the inverter, as it should be, but the AC comes out, and then this is inside of like a utility room, and then on the outside of the house, this particular enclosure is on the outside of the house, and the wire punches through the wall and comes into this AC disconnect. Unfortunately, this is on the outside of the house, and this is on the inside of the house, so there's no way to visibly see this disconnect from the inverter. And so the problem with that, and the reason that the code in general doesn't allow that, is that, say you're working on this inverter inside the utility room, you've turned this switch off, it would be advisable to lock the switch off in the open position. That's why this thing has a tab right here. But if you turned it off and you didn't think about it, the homeowner could come home from work at 4 o'clock or whatever, they come home early, they want to talk to you about something, and they see this door open on the side of their house, and they go, oh, those stupid kids from the neighborhood, they've turned my system off again. They come over here and turn it back on again, not knowing that you're on the other end of the wire trying to reinstall the AC wiring into the unit, and you get French fried. So keeping the disconnects within sight of the equipment in general in the NEC is the requirement. There are some stipulations for disconnects that are not within sight, and then you just follow the rules for those, but they typically require some type of a lockability where you can lock the switch in the off position to prevent people from inadvertently turning it on. An inverter output circuit is located at the opposite end of the bus from the utility supply, and this is not a general requirement. This is just if you're using the 120% rule, which has historically been a very common option used to interconnect the solar to a house, then we'll have this sign that says don't relocate the overcurrent device and asking you to put it at the opposite end from the utility supply. However, that being said, with the energy storage projects that are coming down the road, things have changed quite a bit. And if time permits at the end, I'll show you some diagrams that explain those different arrangements that you're going to need to use because of the fact that we're bringing in, especially with AC coupled inverter battery systems, We have, Tesla, Enphase, all these different, Franklin is another new company. These companies are doing AC coupled systems. So your AC supply to the bus bars are well in excess of the 120% rule. And so there's got to go about doing it differently. And so I've written some articles on this, and I'm happy to show you the different ways that we can do it and still be in compliance with the code without having to rip out the service equipment. That's the key point. If you don't have to rip out the service equipment, unless it's falling apart and in disrepair, I would never recommend replacing somebody's service equipment. So I would always recommend doing it a different way, because it's going to be less expensive to do it differently without having to replace the main service equipment. So system markings, labels according to approved plans, and so making sure whichever version of the code we're on, we need to make sure we have the right signage in the different places. By the way, we have reduced the amount of signage quite a bit, even in the current code that California is under, and come January 1 of 2023, there'll be even less signs required. And so if you really hate signs, you'll be happy that we get to those newer codes. System markings, labels, and signs according to approved plans. Here's an example. It's kind of a funny one. Kind of chuckle every time I see this one, but as you might expect, signs can be a little bit ugly, especially all those red signs and things like that. Customer didn't like the looks of that, and so they did mask the meters. That was kind of good of them that they did that. And then they had the stucco guys just go right over everything, and so they obscured all the signs that had been so nicely installed. And it looks pretty, but not necessarily what you want to see. And so our plans should call out what kinds of signs we need to have, what the requirements for those signs are. We get into rapid shutdown, we'll see some of that. So we want to see those signs if they're called out in the plans. Connection of the system to the grounding electrode according to the approved plan. It's not all that common that we would have to install a grounding electrode, but on older homes it is more common for sure. And so in a lot of communities, especially with older homes, they'll have water pipe grounding, which if all the grounding is, if all the pipes are metallic, they're excellent grounds. But unfortunately, what happens over time is those metal pipes get replaced with plastic pipes, and then we lose our connection to earth. And so most jurisdictions in California, because of this issue, if you're going to do an electrical project on an older house, you have to show that it either has an existing UFR ground, and even if it has an existing ground rod, many communities will require an additional ground rod installed 6 feet or more away from the original ground rod. So you have at least 2 ground rods. And that has nothing to do with solar, quite frankly. It's really just a general electrical requirement. And it is true that there are a lot of substandard grounding at homes in California. And so if you're the first person to do an electrical project at a home, in an older home in California, then installing grounding electrodes is not an uncommon thing to have to do. Access and workspace can be particularly challenging in California because of our high growth rates of our vegetation. And so a lot of people don't like the looks of their meters and things like that, and we'll often want to put our inverters right next to our meters. And so you've got banana trees growing up in front of things or whatever it is. It's pretty common to see that, to try to mask or provide some kind of screening over stuff that people don't like the looks of. And of course, that vegetation often is in the workspace of the electrical equipment. And just for quick review, the workspace on any piece of electrical equipment in the residential voltages would require at least 30 inches wide or the width of the equipment, if the width of the equipment is larger than 30 inches wide. And then it will require 3 feet back from the front of the equipment. So 30 inches wide or more, and then 36 inches back from the front of the equipment. And if you don't have that, the only way you can get that approved is for the local jurisdiction to provide an exception. And that is also allowed in 110.26 in the code, in 26 and 27. So, but obviously it's better if you can do it from the beginning, have the full available workspace, and it's certainly a lot nicer to work on stuff when you have the full available workspace. On the left-hand side there, you see an old school battery system, and we're not going to see any of those installed in the last probably 8 or 10 years, but here you have a flooded battery. In order to work on this electrical panel over here, you'd either have to sit on top of the battery enclosure or stand in the battery enclosure, and then I would recommend not sitting down if you're standing in that enclosure. That could be kind of a hot seat right there. But anyway, having proper access to equipment, sometimes, especially with batteries, we do have to think it out, and it's not simple. It's not easy. We have to really put some thought into that when we're laying out an equipment on a system. And that's one of the reasons why, if you can have that in your plans and get that approved and talk to the local jurisdiction, then those issues can be resolved ahead of time and don't have to deal with that in the field. Rapid shutdown. Everyone loves to talk about rapid shutdown. Unfortunately, I'm the one that coined the phrase. Although it's maybe not super descriptive, most people know what we're talking about. Rapid shutdown is designed for firefighter safety in the event that they would have to get on the roof and work around this equipment. It enables the equipment to be put in a lower hazard condition. And it's going to have this sign that you see in the bottom right corner: solar PV system equipped with rapid shutdown. Turn rapid shutdown switch to the off position to shut down PV system and reduce shock hazard in array. And so that's the sign that the code asks to see. And here's an example. This particular example is a microinverter system where we have modules and microinverters up on the roof. The modules could be up to 60 or 80 volts when they're an open circuit, but the conductors on the output going to coming out of the microinverters is going to be shut down to 0 volts, which is below 30, within 30 seconds. And that AC line goes directly into the service equipment on the outside of the house. So there's an example of a microinverter system. And of course, there are other methods of providing rapid shutdown compliance. And so UL 3741 is a new standard, PV hazard control. This is actually an old slide, so it's not still under development. It's actually, it has been voted on and is available. There are a few products out there that have passed PV hazard control stipulations. That standard will be under some revision over the next several years just because it's very new and very complex. There's probably half a dozen products currently on the market that have this PV hazard control listing, and it would include some Tesla products, some SolarEdge products, some Enphase products. So there's been some really good progress there. Of course, the 80 volt limit, which has been around for several years as a requirement in California ever since the beginning of 2019, or 2020 is when it actually went into effect in the 2019 California Electrical Code. So we can certainly use Enphase microinverters or other types of microinverters, SolarEdge optimizers, APC switches, AP system switches, There's a variety of switch technologies out there where we can turn the modules off at the module with these switches. Tygo, another example. So quite a few products on the market. We still have the option of using non-metallic, the non-metallic option, which is option 3 in the requirements for PV for hazard control in the array. Very few companies are using that, but Tesla did use it for a while until they got their 3741 listing, and there may be a couple of others. Some folks on the call might be familiar with those as well. Okay. Rapid shutdown for battery systems. So without going in any detail here, in the 2014 NEC, which was the 2016 California Electrical Code, there was a basic requirement to shut down the whole PV system, which would include batteries, outputs, and stuff like that. The current version of the code that we're on, which is the 2019 California Electrical Code, only requires the PV system to be shut down. And we spent a lot of time in the 2017 code defining what a PV system was. In the 2014 code, the PV system would include any battery system that was installed with it, even loads and things like that that were part of the system would be considered part of the PV system. In the 2017 code, what we did is we pared down the definition of what a photovoltaic system was to just the power producing system. And so when we apply rapid shutdown to the PV system, it does not include the energy storage system. That being said, the energy storage system has its own requirements for disconnects and external shutdowns and things like that. And so we can get into those details as well. So there's our sign for rapid shutdown with PV systems. If we happen to have a building, this often happens more with commercial buildings than it does with residential, but occasionally in a large residential, we can increase the size of the system. There's some very large homes in the Tri-County area. And so if we have an older system that's been installed under one version of the electrical code, and then we have a newer system that's got to be installed under the current 2019 California Electrical Code, then the code requires us to have a plan view of the roof showing where what is still energized. The dotted line shows areas that remain energized after throwing the rapid shutdown switch, turning the switch off. All right, the switch needs to have this sign next to it. There's another sign. So what are the compliance options? We can use string inverters with DC converters or shut-off devices at each module. So that would be SolarEdge with their optimizers, or AP systems or other types of Tygo or whatever that would have switches at the modules. Microinverters, of course, work well, and they can be for up to 4 modules per microinverter. The current products that are on the market. This new UL 3741 PV hazard control, and it's still an option and will be for building integrated PV arrays with no exposed metal and installed more than 8 feet from grounded metal. Very difficult to comply with that, by the way, but it is still an option, and it is in the code. So the standards in place to verify rapid shutdown equipment. So we have rapid shutdown listed equipment. All of our inverters are going to have listings for rapid shutdown. Microinverters are going to have it, things like that. And then there might be a combination of listed rapid shutdown equipment used in a PV hazard control system. That would include things like the Tesla listing requires a mid-circuit interrupter that they use. It's kind of like an individual module switch, but it interrupts midway in the unit in the system. They might have a couple of those in a PV array. depending on the array design, things like that. And so those individual units are going to be rapid shutdown equipment listed, and then they're specified as specific products that have to be used in the PV hazard control system. Okay, load side source connections. See, I'm just going to hit these. This is super quick. 120% rule basically is not the only rule, but it has certainly been the most used of all the rules. And that's where we say don't relocate the overcurrent device. We have the main breaker coming in here, and then the PV system at the opposite end. And so that's, you know, on 100 amp service, it's only a 20 amp PV system that you can put in, which is maximum of 3,840 watts. Now, with the 200 amp service, obviously everything doubles, and so the 7.6 kilowatt inverter is by far the most common inverter sold in the United States, and it has this do not relocate the overcurrent device set up. However, the sum of the branch breakers is going to be the rule that we're going to use most often moving forward, particularly with our AC output energy storage systems. And we have to do it that way because we just don't have the capacity to do it with the 120% rule. And so what we're dealing with here is, let's say we have a 200 amp bus panel here. We could have a combination of loads and interactive inverters, and as long as the sum of those breakers is not greater than the bus bar rating, we're okay. Now, it's challenging to do that in most applications, and so normally what we're going to do in an application like this is come off of this panel with another 200 amp breaker. So take all the breakers out of the existing panel, and let's say this is an existing house and they've got 30 breakers in their panel. A lot of these systems, what we're going to do is actually remove all the breakers from the main panel. We're going to put one 200 amp breaker in there and go off of that into other panels, or we're going to put two 100 amp breakers or some combination that adds up to 200 amps. And I'll show you an example of that. But so often we might have a 100 amp breaker going to a non-backup set of loads, like your electric range, your electric water heater, things like that are 240 volt loads. And then we're going to have a breaker, 100 amp breaker, going to it could be a microgrid interconnect device. It could be a multi-mode inverter where we're going to back up the rest of the house from that system. Very effective way to do it. And it allows us to put in much more PV, up to, certainly if we're using a 200 amp breaker out of this panel, we could go all the way up to 200 amps, which is 38 kilowatts. That's pretty big on a 200 amp service, more than most people would ever need. Of course, I need it on my house, but that's another story. I'm weird. But even with a 100 amp service, we could do a 100 amp breaker out of our main panel and backfeed 19 kilowatts without having to change out the main service. So very, very important item that a lot of people don't know about because they're so used to using the 120% rule. So I call this the modified Hawaiian tie-in method because basically what we do is we take all our breakers out of that main panel, we just stick a 100 amp breaker in there, and then we come over to a 200 amp panel, right? So we feed that 200 amp panel with a 100 amp feeder breaker out of the main panel. All the rest of the circuits are pulled out of that panel and put into this. And now we can double the amount of PV. So we could have a 50 amp PV and a 50 amp ESS in here, no problem. And we haven't violated a single thing in the code, and all the excess power can come back up through here. And because we've used the sum of the breakers and not the 120% rule, we can feed back 100 amps back through that panel up to the grid. So very, very important point. A lot of people don't know this yet, but hopefully catch on to this. Saves you a lot of time and money. A 200 amp main lug panel is an inexpensive device. There is some wiring involved, but if we're talking about energy storage, there's almost always some wiring involved. A lot of folks want to be able to just walk in and put in a whole house backup system and do it in a couple hours, it's going to take more than a couple hours. It usually takes a day or two, at least. Center-fed panels. A lot of people like to talk about center-fed panels. Code allows specifically that we can use the 120% rule on dwellings with 120 with center-fed panels. So on a 200 amp center-fed panel like this, we could put a 20 amp breaker on either end, or we could put a 20 amp breaker on both ends, or a 40 amp breaker on either end, not both ends. That is totally allowed, and that was getting away from the problem that had occurred where a lot of jurisdictions were requiring people to change out perfectly good center-fed panel devices. Okay, and it was because of an article they read that was not really accurate. Okay, so engineering supervision, that's one of those areas where I'd like to see a lot more people using this particular provision. And that's where, when we have large switchgear, 3,000 amp, 4,000 amp switchgear, 2,000 amp switchgear, any loads that we put in a panel like that are done under engineering supervision. And then if we're particular about where we put our PV inverters and installing them on there, we can show through fault analysis that there's no way, there's no physical possible way, even if all the circuits were off or all the circuits were on or any weird combination thereof, there's no way to overcurrent anything in this equipment. Engineer can do those calculations very well and very easily. And so the 120% rule does not apply whatsoever. All we're doing is making sure in this particular, this is an example of a project I was personally involved in. There was a 3,000 amp main bus with 2,000 amp branches coming off of it. And all we had to do is show that there was no way that we would ever get more than 2,000 amps on any one branch, and no way that in any possible configuration of loads and sources that we could ever see more than 3,000 amps on the main bus. That was a very easy solution. The calculations took about maybe an hour, maybe a half an hour, and it saved a ton of money and made the installation much cleaner. So like to see more people using that option as well. Marking, if we have a panel board that has more than one source of supply, then we have to identify what sources of supply are there. If we're going to backfeed circuit breakers, then they cannot be marked line and load, because generally line and load marked circuit breakers are designed for power flow in one direction. Here's an example of fastening. We're not required to fasten plug-in breakers when we're connected to the output, the interactive output of an inverter. So the interactive output of the inverter is the one that interacts with the utility. If it ever loses utility, then it automatically shuts down, and so there's no need. If that breaker were to come loose, it'll just shut the inverter off and no damage will be done. However, if we're on a backup panel and we're feeding backup loads from an inverter, that is not the interactive side of the inverter. And of course, anything, if we wanted to backfeed a circuit breaker on the backup load side of say a multi-mode inverter system, then that would absolutely have to be installed, fastened accordingly, the way any other backfed breaker in a sub-panel would have to be installed, according to Article 408. Okay, so some of the energy storage configurations we have out there, we call these DC coupled or DC interconnected systems, where we have we'll be bringing the PV array and the energy storage together on the DC side of the multi-mode inverter. There are quite a few of these products out there, including Generac is certainly a common one, and there are others. And so this would be a DC connected energy storage system and a DC connected PV system. And the PV system actually has a DC disconnect for the PV system disconnect. So the disconnects that are over here whether they're going for the interactive side of the inverter or whether they're going to the standalone loads, those are not PV system disconnects. They are interactive disconnects, or they could be load disconnects. The actual source disconnects in this example are all on the DC side. Retrofitting existing PV systems will become commonplace. A lot of those systems are going to be more configured in this manner. And with an AC coupled system, and with those AC coupled systems, we might be feeding it through a multi-mode inverter and connecting it to the backup side of the multi-mode inverter. So the existing PV system would actually be, the circuit breaker would be taken out of the main panel or wherever it was installed, and then be installed in a panel where it includes the backup system loads. This is kind of a hybrid in that the energy storage system is being supplied on the DC side. Of course, if this was a Tesla system, then the inverter is incorporated into the power wall, and then they connect the power wall through a what we call a microgrid interconnect device, which in their case is called a gateway. Other folks call it, and Enphase calls it their smart switch. SolarEdge calls it their backup interface. Franklin calls it their A-gate. There's all these different products out there that provide that microgrid interconnect device in a separate enclosure, which isolates that whole portion of the house from the utility grid. In a multi-mode inverter, that microgrid interconnect device is inside the inverter. And there are actually two AC outputs, one AC output on the grid side of the microgrid interconnect device, and the other output on the backup load side. So now let's talk about the residential code. So last summer, the California Residential Code adopted the new requirements of the 2021 International Residential Code as it applied to energy storage systems. And so it's important for us to talk about these even in an inspection type of a discussion, because it is how we determine whether something is in compliance with the code, and by doing that, our inspectors will see that things are done as the code requires them. So it's very visual and descriptive when we get into these parts of the process. Now, there's a basic exception that is very confusing, and I don't like the language. Just want to explain it to people that are maybe confused by it. ESS listed and labeled in accordance with UL 9540 and marked for use in residential dwelling units do not have to meet any of the requirements of R327 in the California Residential Code. Okay, there are exactly zero products that meet this requirement. I call this the unicorn mark. Nobody has this unicorn mark, and nobody's seen this unicorn mark because it's a unicorn. So we don't have products currently on the market that can pass this particular requirement. Maybe we will in the future. We don't have any now. If somebody claims that they have it, that's news, because that would be really big news in the solar world. It's not, nobody has it yet. So we follow these rules. That's the basic rule, is we follow these rules. So there are exceptions. There's a really weird exception about repurposed unlisted battery systems from electric vehicles. Whatever. Haven't seen one yet. I'm sure we'll see them in the future. Not going to worry about that for right now. Now, this the legislative language that I'm showing you here with the strikeouts is actually the difference between the 2016 CRC and the 2019 CRC, actually, I'm sorry, it's the difference between the 2019 CRC and the adjusted 2019 CRC with these 2021 amendments. That would be the right way to say it. Okay, so the 2021 amendments took out some of the wording, but then has this additional wording in here: the individual units shall be separated by at least 3 feet of spacing unless they pass large-scale fire testing. And so that's the basic rule. And we'll get into the details of what that means. locations where we can put these things. We can put them in detached garages, detached accessory structures, attached garages, outdoors on the exterior walls of the house, located at least 3 feet from doors or windows directly entering the dwelling unit. Directly entering the dwelling unit means going inside the living space of the house, not the attached garage. Okay, you can put ESS on the outside of an attached garage, and we'll show you a diagram of that in a second. And you can go right up to the garage door, you can go right up to the side door of the garage, right up to the window of the garage, not a problem. You cannot go up to the window of a bedroom, for instance. It's got to be at least 3 feet away from that bedroom window. Another location enclosed inside a building, enclosed utility closets, basements, storage, utility spaces within dwelling units with finished or non-combustible walls or ceiling. However, if you have walls and ceilings of unfinished wood frame construction, then you've got to put 5/8 type X gypsum on that exposed wood to protect the wood. And you're not allowed to install ESS in sleeping rooms or closets or spaces opening directly into sleeping rooms. So like if you had a nice, really big walk-in closet in your master bedroom, you would not be allowed to use that because that opens into the sleeping room. Okay, so what I did is I actually took my house and I showed where, because of these rules, the yellow places are places that would be acceptable more than 3 feet from openings into the dwelling unit. And so what you find out is on the main part of the dwelling unit, which is this part, that's the main part of the dwelling unit. That is the dwelling unit. That's where your bedrooms and living rooms and dining room, kitchen, all that kind of stuff are in this part, this square. The only places you could actually legally install an energy storage system on the outside of the house would be here, here, up here in the top left, a tiny little space, not big enough to install anything there. And then as you come off of the garage, there's a larger space right there. But as you can see here, the garage exteriors and the garage interiors, and we'll get to that in a minute, are by far the most likely place if you're going to hang the equipment or install the equipment on the structure of the house. It's going to be on the attached garage, assuming you have an attached garage. That's the most likely place. Now, there is a series of energy ratings that tells us what the maximum size that can go in any one place. And so the aggregate rating that could go inside of the dwelling unit, which would include utility closets, basements, and storage or utility spaces, would be 40 kilowatt hours. In attached garages or detached accessory structures, we can go up to 80 kilowatt hours. On the exterior wall of the building, we could go up to 80 kilowatt hours. And outdoors on the ground, in a ground-mounted installation, you could put 80 kilowatt hours. And the State Fire Marshal's Office about 3 months ago issued a bulletin that says that you can go up to all 4 of these items. So you could actually install 280 kilowatt hours of energy storage on a home. That would be an extraordinarily large energy storage system. But being in California, there are a lot of movie stars out there, and being in Santa Barbara region, Tri-County region, there's plenty of movie stars that have massive houses that probably need at least that much energy storage, because those poor people might run out of power someday, and we have to care. No, we don't have to care. We just have a code that covers it. Don't have to care at all. Fire detection. If we're going to install energy storage inside the dwelling, then we need to have smoke alarms to let people know that those things, that if we have a problem, to alert people. And if it's in an attached garage, somewhere where a smoke alarm can't be used according to its listing, then we need some type of a heat detector. And there's been a lot of discussion about this, and we don't have really time to go into a lot of detail about heat detectors and heat alarms and things like that. There are a few products on the market that will probably do the work. There's a lot of folks kind of scratching their head on this one. So if it's on the outside of the garage, would not need this. If it's on the inside of the garage, then it may have to be addressed. If the garage never gets above 105 degrees, which in some places in California, that's true, then a smoke alarm would be acceptable. So that is, smoke alarms are not completely disallowed in garages. It just can't be super hot and it can't be super cold. And hey, California's a great place, so why not? Protection from impact. So ESS installed in a location subject to vehicle damage shall be protected by approved barriers. We're going to talk about that in just a second here as we're wrapping up. And I know we're coming up. We got about 15 minutes left, so I think we're going to land the plane right on time. ESS that includes batteries that produce hydrogen or other flammable gases during charging, during normal conditions here, the only products that do that would be flooded lead acid batteries, shall be provided with mechanical ventilation. So the upshot is there are exactly zero UL 9540 battery systems, energy storage systems that include flooded lead acid batteries. So therefore, this section of the code is essentially a moot point because it is impossible to generate hydrogen or flammable gases under normal charging conditions. So that's the point here. This is not saying about abnormal conditions and stuff like that. That's why we have smoke alarms, heat alarms, all that kind of stuff for those kind of situations. Ventilation requirements from day one when we're talking about battery systems has always been about normal charging of flooded lead acid batteries that have a propensity to give off hydrogen when they're being charged hard. And that hydrogen, if it is collected in a box that's sealed, can establish an explosive mixture. And so, again, this is a section of the code we really don't have to worry about right now because we're using lithium-ion batteries in our ESS, and we're starting to use valve-regulated lead acid batteries in our ESS as well that are UL 9540, neither of which require ventilation. Important point. Electric vehicle use. This is kind of an apple pie motherhood statement in the current code. It says temporary use of a owner's or occupant's electric powered vehicle to power a dwelling unit while parked in an attached or detached garage or outside shall comply with the vehicle's manufacturer's instructions and the National Electrical Code. That's what NFPA 7 is. And that's the generic truth of all things. All products, they have to be used according to the manufacturer's instructions, and if they have electrical requirements that are found in the NEC, then you got to follow the NEC. But we will see electric vehicle use for backing up people's houses routinely within 5 years. Within 5 years, we will see many products coming on the market. Of course, everyone's probably familiar with the Ford Lightning product, which is already doing some backup capabilities already. But we're going to see full-on utility interactive inverters with microgrids where the electric vehicle is interacting with a microgrid, holding up an entire house. We have, a lot of our electric vehicles have anywhere between 50 and 150 kilowatt hours of energy storage, which far, in a way, exceeds the vast majority of stationary energy storage systems. It is by far the most economic way to do energy storage. And so we will be seeing a lot of that. And so how we electrically connect into it, obviously the electrical code is going to have a lot to say about that. But parking our car in the garage has been allowed and will continue to be allowed. A lot of folks want to try to regulate how big an electric vehicle you can put in your garage. And that would be literally like regulating how big of a Suburban you could put in your garage. I'm sorry, it's your garage. If you can fit it in the garage, you can park it in your garage, if that's what you want to do with your garage. So those folks that want to regulate that, they just need to find something else better to do with their time. And you can quote me on that. Okay. So we only have a few minutes left, and I'm going to hit this next section fairly quick. So we talked about for energy storage systems, we have to be UL 9540 and has to be installed according to the manufacturer's instructions. Very, very important point here. Manufacturer's instructions are very detailed in the energy storage system. So don't assume that you know just because you've installed an energy storage system in the past or whatever how to do it. You have to read the instructions. And I know I'm a male, so it's a real challenge for me to read instructions. I have to do it. I have to sit myself down. I have to open it up. Okay, yeah, right, yep. Because I know the inspector usually is much better at reading instructions than I am. And if they see that I've installed it inappropriately or in a way that is inconsistent with the instructions, then they will ask me to fix it. And that could take a lot more time than it took to just install it in the first place. Meets the size limits. Individual ESS can be no larger than 20 kilowatt hours. And you'll notice that manufacturers throughout our industry have been very careful to keep residential ESS within that 20 kilowatt hour limit. And so these are size requirements that are currently in the California Residential Code. Individual units have to be installed within, individual units can be no closer than 36 inches apart unless they have large-scale fire testing. Now, large-scale fire testing usually as a result of a UL 9540A. This is not a typo. It's an A at the end of UL 9540. It's a special set of test protocols that determine a variety of installation parameters that the manufacturer has to pass if they want to do something other than what the basic code requirement has as of 36 inches. And by the way, almost every single manufacturer of an ESS wants to do these UL 9540A tests because it is, if you're doing 2 units, one on either side of the inverter, it's actually really easy because the inverter needs spacing between other equipment, and it's pretty easy to get that 3 feet, no problem, without having to do any large-scale fire testing. However, if you wanted to put them both on one side, having an extra 3 feet of room can be a real pain in the butt. And here's an example of if I wanted to go to the full 80 kilowatt hours that's allowed in the code in my attached garage, and I had a 3-foot requirement, then I would have, this is how I'd have to install it. It would take fully 18 feet of wall space. And I can tell you for a fact that there are very, very few residential garages that have 18 uninterrupted feet of wall space. Now, if you were lucky and there happened to be a window in between these, you know, that would just be straight up luck. But that's an enormous amount of wall space that would be required if you're going to have no fire testing. So that's why I'm saying that almost every ESS company is going to do these large-scale fire tests, whether it says they have to be 6 inches apart or a foot apart or whatever they say as a result of that testing. That's going to really dramatically reduce the wall spacing. In this particular case, it went from 18 feet to 14 feet, but it might even be quite a bit less than that. So just be aware that there are big differences when we get into that energy storage testing, the fire testing that's required, large-scale fire testing. Okay. So we talked about attached garages, separated from the dwelling space according to R302.6, which is the basic separation requirements of sheetrock and things like that. It's a kind of a fire-rated wall. It's not really truly a fire-rated wall. Just following the code requirements. Again, windows and doors directly entering the unit. Showed you an example of that on my home. And here's an example of, you know, no more than 40 kilowatt hours inside the house. And again, if you have unfinished walls or ceilings, you've got to cover those. And detached garages, detached accessory structures can go up to 80 kilowatt hours. And of course, outdoors on the ground. And there could be different arrangements. If you're mounting on the ground, there might be clusters of these things or whatever that are set up. Impact protection recommendations. Now, there's been some proposals put into the residential code to actually codify this. I believe it's going into the California residential code. I think these things have been accepted for the California electrical code. that we can install the ESS on the sidewalls of the interior garage and install, if we can put it on the end wall of the garage as long as it's 48 inches off of the ground, or if we're below 48 inches off the end wall, then we can use parking curbs and other things. And so there's a few different versions of that, but here's an example of inside a garage. You could put it in these yellow areas where right up to the edge of the garage door, the windows or side doors, no problem. If you're going to put it on the end wall, then it would have to meet the requirements of having some, like a parking curb or something like that. Bollards are pretty difficult to install in most garage slabs and things like that, so be careful with that idea. A parking curb, I think, is a much less obtrusive method, and then of course the height could work as well. The reason we're not allowing anything over here is because within 3 feet of a door entering the dwelling unit. So this interface door is entering the dwelling unit. We can't get within 3 feet of that, so that basically makes this whole area not allowed. Okay, so it's just some examples. 706.7 covers disconnecting means. And for residential systems, we just have to have the nominal ESS voltage. We're not required to have the available short circuit current and clearing time and all that other silly stuff. It's wonderful stuff, I should say. As an engineer, it's fun, exciting information, but it's not required for residential. This is one that gets a lot of people confused. It says dwelling units shall not exceed 100 volts between conductors or to ground, except the big exception is where live parts are not accessible during routine ESS maintenance. Well, no 9540 device requires routine maintenance, period. So voltage exceeding 100 volts to ground is allowed, and you could go all the way up to 600 volts, no problem. So UL 9540 precludes the need for these voltage limitations. So there's essentially no voltage limitations on your UL 9540 stuff. And this part of the code really doesn't apply to anything. 9540 is still a new standard. There are several products certified to it. There's a new installation standard that's used primarily for commercial and industrial applications, UL 855. It has informed a lot of our residential codes as well. Interconnection standards are continuing to evolve. So PG&E and Southern California Edison are changing rules on a pretty regular basis as we go forward with energy storage systems and PV. And there'll be more revisions to the IFC and the IRC and the IBC that will come into the state of California. Lots have changed. There's new certification processes. And we do need to make room for lead acid batteries. That's kind of the new UL 9540 requirements are allowing for lead acid batteries. So with that, we have 2 minutes left and haven't gotten a lot of questions in the chat. I hope there hasn't been a lot of snoring out there, but open it up if anybody's got any questions at the end here. And if not, there's my email address. I answer questions from jurisdictions all the time and from electrical folks, contractors. I do it as best I can. I'm a consulting engineer, so that's my business. But if you've got a quick and simple question, I try to answer those questions. And if you want to hire me, of course, you can do that too. I'm going to turn it back over to April.
Great.
Sharing.
Great. Thanks, Bill. 2 minutes, guys. Get your questions in.
So thanks a lot. That's really awesome information for my purposes. The allowable locations is where I'm going to use this to help advise clients as a contractor. Just the recording. I'll need this recording in the reference material and what you put together. Very well organized. Thank you very much.
Great. Anyone else? Well, with that, April, do you have anything else that you want to add about 3C and the great programs you guys have?
I'll just let folks know that we will be following up with an email to everyone that registered for this session with a link to the slides and also a recording. So in case you missed something, don't panic. And I think we can end on time. That was wonderful. Thank you so much, Bill. And thanks to everyone for attending. Have a great rest of your day.
Take care, everyone.